So what we have here is a setup that we put together to test a motor and also the controller for the motor. Now this controller we got from Banggood, and the motor itself we also got from Banggood. Now that's a 12 volt to 24 volt, and in some cases it says up to 36 volt DC motor, and the controller here is from 6 to 60 volt control and up to 30 amps. So what we'll do now is we'll actually power up the motor itself. So we simply do that by putting power onto our power supply. We put our load on, which is also powered the speed controller. Now that speed controller can be switched on or off, with reference to the switch there, and the potentiometer here allows us to control the revs per minute, percentage. So what we'll do now is that we're actually power up the motor. Now we've got power on as far as the power supply goes, and the speed controller is switched on. And what we'll do here is just turn on the motor, and we can actually have very fine control with the speed controller for the motor, and we'll show that in a minute. So what we're doing here is just slowly ramping the motor up, and we're at 40% capacity off the speed controller. And if we rev it up further, you can see that it's a very smooth control. We're now at 70%, and keeping in mind that we're only running this at 12 volts at the moment, we can actually improve that, which will actually make the motor run faster. We'll ramp it up to 100%. So that's a little test jig, to check the motor, make sure the motor works, and also make sure that the speed controller is doing what it's supposed to do. Alright, so what we're going to do now is that the motor is quoted at running between 12 and 36 volts. The first operation we looked at was at 12 volts. We'll now run that at 24 volts, and we'll see what happens here. So 30%. 60%. Has a lot more drive and torque, the higher voltage. We'll drop that down. So now we'll adjust the voltage to 36, and we have tested the motor at 36. Put the controller back on, and we'll go 30%, so 30%, 60%, you do have very fine control with the speed controller on this motor. And now we'll go to 100%. I think this will be quite applicable for a number of upcoming applications that we're going to be using the motor and the speed controller in. And the other important aspect, as you probably saw on the power supply, is that as the voltage went up and the speed controller increased the revs per minute range, right, the current draw will also increase with reference to the motor. You'll also find that depending on what voltage you operate the motor at, whether it's at 12 volts or up to 36 volts, that if the motor is put under load, then your current draw is also going to increase.